Modern computers consist of several different components working together. In this video, we're going to be looking at some of the main components, starting with the power supply unit. The power supply unit is the piece of hardware that is used to convert the power provided from the outlet into usable power to the motherboard and other components. The motherboard is the backbone of the PC. The motherboard is also known as the MOBO, or the system board, and on Apple computers they call it the logic board. On desktops, motherboards, cases, and power supplies all come in different sizes called form factors, and all three of these must be compatible to work properly together. Each motherboard supports a single type of CPU and a short list of memory types. In a desktop, the motherboard is mounted inside the case, and it is securely attached via small screws through pre-drilled holes. Power from the power supply unit is delivered to the motherboard by use of a specially designed port. And the front of the motherboard contains ports that all of the internal components connect to. And a single socket slot houses the CPU. The CPU stands for Central Processing Unit, and it's the computer component that's responsible for interpreting and executing most of the commands from the computer's other hardware and software. All sorts of devices use a CPU. Intel and AMD are the two most popular CPU manufacturers for desktops, laptops, and servers. You're probably going to see many different names used to describe the CPU, including processor, computer processor, microprocessor, central processor, and, quote-unquote, the brains of the computer. A modern CPU is usually small and square, with many short, rounded, metallic connectors on its underside. Some older CPUs have pins instead of metallic connectors. The CPU attaches directly to a CPU socket, or sometimes a slot, on the motherboard. The CPU is inserted into the socket pin side down, and a small lever helps to secure the processor. After running even a short while, modern CPUs can get very hot, and to help dissipate this heat, it's almost always necessary to attach a heat sink and a fan directly on top of the CPU, and typically these come bundled with a CPU purchase. Other more advanced cooling options are also available, including water cooling kits and phase change units. The clock speed of a processor is the number of instructions it can process in any given second, measured in gigahertz. For example, a CPU that has a clock speed of 1 Hz can process one piece of instruction every second, and a CPU that has a clock speed of 3 GHz can process 3 billion instructions each and every second. Some devices have a single-core processor, while others may have a dual-core or quad-core processor, and having two processor units working side by side means that the CPU can manage twice the instructions every second simultaneously, drastically improving performance. Some CPUs can virtualize 2 cores for every one physical core that's available, known as hyperthreading. And this means a CPU that may only have 4 cores can function as if it has 8, with the additional virtual CPU cores referred to as separate threads. However, physical cores do perform better than virtual ones. And with the CPU permitting, some applications can use what's called multi-threading. If a thread is understood as a single piece of a computer process, then utilizing multiple threads in a single CPU core means more instructions can be understood and processed at once. Some software can take advantage of this on more than one CPU core, which means even more instructions can be processed simultaneously. Another component of a CPU is cache. CPU cache is like a temporary holding for commonly used data. Instead of calling on RAM for these items, the CPU determines what data you seem to keep using, assumes you'll want to keep using it, and stores it in cache. Cache is faster than RAM because it's a physical part of the processor. More cache means more space for holding such information. Whether your computer can run a 32-bit or 64-bit operating system depends on the size of data units that the CPU can work with. More memory can be accessed at once and in larger pieces with a 64-bit processor than a 32-bit one, which is why operating systems and applications that are 64-bit specific cannot run on a 32-bit processor. The gateway between the CPU and other components is a set of interface controllers generically called the chipset. And the chipset is like a spinal cord that controls most of the devices responsible for communicating with the outside world. Traditional chipsets include a north bridge with a memory controller and graphics card interface, and a south bridge containing slower expansion card interfaces and various peripheral storage and communications controllers. Following the memory bus from the north bridge, you arrive at the RAM, which is the random access memory, or the physical hardware inside a computer that temporarily stores data, serving as the computer's working memory. Additional RAM allows a computer to work with more information at the same time, which usually has a dramatic effect on the total system performance. And some of the popular manufacturers of RAM include Kingston, PNY, and Corsair. The purpose of RAM is to provide quick read and write access to a storage device. Your computer uses RAM to load data because it's much quicker than running that same data directly off a hard drive. The two main types of RAM are static RAM, or SRAM, and dynamic RAM, or DRAM. Both types are volatile. And SRAM is faster but more expensive to produce than DRAM, which is why DRAM is more prevalent in today's devices. However, SRAM is sometimes seen in small doses in various internal computer parts, like with the CPU and as hard drive cache memory. Following the high-speed graphics bus from the North Bridge, whether it's AGP or PCI Express, you arrive to the video card. And the video card is an expansion card that allows the computer to send graphical information to a video display device, such as a monitor, TV, or projector. Some other names for a video card include graphics card, graphics adapter, display adapter, video controller, and add-in boards. Many companies manufacture video cards, but almost every one includes a graphics processing unit, or GPU, from either the nVidia Corporation or AMD. The video card installs in an expansion slot on the motherboard, and while most video cards are of the PCIe format, which is the quickest format, video cards can come in other formats as well, including the older PCI and AGP format. In a desktop, since the motherboard, case, and expansion cards are designed with compatibility in mind, the side of the video card fits just outside the back of the case when installed, making its ports available for use. From these ports, you can typically connect either an HDMI, DVI, or VGA compatible monitor for display. And as far as display types, there's 5 main display types. The first popular monitors were called CRT, which stands for cathode ray tube. And these monitors consist of a vacuum tube containing one or more electron guns and a phosphorescent screen used to view images. They dominated the market before flat panel displays arrived in the mid-2000s. There's also OLED, which stands for Organic Light Emitting Diode, and organically glowing materials used in OLED panels don't require separate backlights, making them far slimmer than other displays. Plasma is similar to OLED in that it emits its own light to produce RGB colors. Cells containing xenon and neon gases emit light when charged. There's also LCD, which stands for Liquid Crystal Display, and this is today's dominant flat display technology, which produces images by blocking or allowing light to pass from the light source behind the LCD display. There's also LED, which stands for Light Emitting Diode, and LEDs are LCD TVs that replace the fluorescent backlight used in conventional LCD displays with an LED backlight. From the North Bridge, we're going to follow the internal bus to the South Bridge, which can be known as the in and out controller hub. The South Bridge typically implements the slower capabilities of the motherboard in the North Bridge-South Bridge chipset computer architecture. The SATA ports are connected to the South Bridge, and this allows the hard disk drive to be connected. And the hard disk drive is the main and usually the largest data storage hardware device in a computer. The operating system, software titles, and most other files are stored in the hard disk drive. It can be abbreviated as HDD, and it's also known as the hard drive, hard disk, fixed drive, fixed disk, or fixed disk drive. Some of the popular hard disk drive manufacturers are Seagate, Western Digital, and Hitachi. And nowadays, you're not limited to a hard disk drive for a large storage space. You also have solid-state drives, which are much quicker than a traditional hard disk drive, but they're also more expensive. Now, also connecting to the South Bridge is a PCI bus, which, if you didn't have a video card, you could use an onboard graphics controller in order to send output to a monitor. And the South Bridge is also where the CPU is going to communicate with your USB, Ethernet, and audio codecs. Following the PCI bus from the South Bridge, you have your PCI slots. And in these slots, you can connect a sound card, a USB card, a modem, and other peripherals to the motherboard itself. Following the LPC bus on the South Bridge, you'll arrive at the Super Input Output, also known as the Super I/O, which is an integrated circuit used to support older legacy devices, such as a floppy disk controller, keyboard and mouses that are not USB, parallel port, and more. Also on the LPC bus is the BIOS chip, and the BIOS, which stands for the Basic Input-Output System, is the program a personal computer's CPU uses to get the computer system started after you turn it on. It also manages the data flow between the computer's operating system and attached components. Without the BIOS, the processor would not know how to interact or interface with the computer components, and the computer would not be able to function. In the next video, I'll show you the importance of the BIOS when starting a computer and how the overall process works from power button to login screen.